Hi, my name is Dmitry. I'm from the Metasite Republic group. Almost 3 years ago, for Wix Turbo, we created a fully async HTTP proxy that was deployed in small data centers across the world. Initially, it served about 100k RPM. Soon enough, we started to handle entire user-of-user traffic, and as proxy matured, it was decided to proxy entire external Wix traffic. And so, the quest for 3 million RPM has begun. According to Wikipedia, resilience is the ability of the system to operate okay-ish under different conditions. It's a very important property of our proxies, because if proxy is down, then Wix is down. And the incidents are given to us to realize the full spectrum of the conditions. So at some point, we started to get out-of-memory error. Not often, not a lot, but this is a sinister sign. Thanks to our excessive logging, we managed to find the offending request, and somehow it was related to Node.js. Here you may see the request that was successfully completed within 2 minutes and streaming 3.3 gigabytes. The problem was simple. If client reads bytes slower than backend produces the byte, then proxy accumulates those bytes into memory. And the solution is simple, like we just need to properly handle buffering. In this case, we need to stop reading bytes from backend if client didn't read it yet. In Netty, it's called watermarks and channel readability. The takeaway from this incident is simple and directly related to resilience. Systems should behave correctly even when we hit some unusual usage pattern. In this case, very large payloads and slow clients. The next incident was far more destructive. Requests flooded not pre-warmed up data center. In cold DC, we have like 10 instances, where normally we need 100 instances to handle the traffic. All these instances were choked up, and until we manually scaled it up, like the incident wasn't resolved. Obviously, the issue is larger than just proxy application, but we can learn some things from this incident. Backpressure is important. The application itself should somehow decide whether it can or not handle this request, hopefully before it goes insane. And this way it's possible to make a fast fallback or at least show some error page. We haven't implemented it yet. It's waiting for the next episode. Why the incident was resolved by manual scaling up? Why auto-scaling didn't help? So the first thing we found out that our startup time is very slow, up to 3 minutes. So we use a KV store that is very big, and its initialization takes all this time. So we tried to improve the performance of KV store, but unsuccessfully. So we decided to proxy KV store. We created another service that has this KV store and exposes it via HTTP, gzipped, and so on. So, and this allows to download and load into memory this huge KV store in few seconds only. So now startup time is below 20 seconds. Faster startup time, faster auto-scaling. And the last part for today, New Relic. Personally, I never liked it. But from necessity a long time ago, with the amazing advances of our monitoring systems, I started to think more and more about getting rid of New Relic. And finally, I may say it, rest in peace, New Relic. But is it reasonable? I decided to investigate, so I did a heap dump of the proxy application and found out that New Relic takes about 75% of memory. Wow. So I turned it off, and back then our main metric for application health was GC post time. So it dropped from 500 milliseconds to 60. So memory consumption dropped, and now we are able to handle even more requests without sacrificing application health. Happily, it operates well with Bootstrap and Loom, so don't expect anything for you. And just to reiterate, async is cool, Don't let slow clients kill your application. Backpressure is essential. Esoteric solutions might be viable sometimes, and our monitoring is amazing. And for the resilience, we have to do whatever it takes. Thank you.